Let's continue with the special counter functions. Pulses can be counted using the forward and backward counter. An input pulse causes an internal counter to count upwards or downwards depending on the configuration. The output is set or reset when the configurable threshold value is reached. You can change the counter direction using the DIR input. An operating hours counter totals the operating time during which the signal 1 is set at the EN signal input, compares this total with the preset time span, and calculates the remaining time from the operating length and time. This means that it is often used to comply with maintenance intervals. The threshold value switch measures the signal frequency at the frequency input and switches the output on or off depending on the set switch on or switch off threshold. Next, we're going to deal with the special analog functions. Using an analog comparator, the output is switched on and off depending on the difference between two analog input signals and two configurable threshold values. An analog signal is evaluated using the analog threshold value switch. The output is set or reset depending on the configured thresholds. The analog amplifier adjusts the level of an analog signal. It can be amplified or attenuated or provided with an offset. The analog value monitor saves any value pending at the analog input. The output is switched on as soon as the current value on the analog input undershoots or exceeds this saved analog value plus a configurable differential value. The analog differential threshold value switch switches the output on and off depending on a configurable threshold and differential value. The analog multiplexer, also known as an analog MUX, outputs 0 or one of 4 saved analog values at the analog output. References can also be made to other current values, for example to specify a value using a potentiometer during manual operation of a machine. The value to be output is selected using 2 binary inputs. The ramp or ramp controller sets 0 or one of 2 fixed steps at the analog output. On transition between the values, a ramp is formed, the slope of which can be set. You can use the PI regulator to implement closed control circuits. PI regulator is an abbreviation for proportional and integral regulator. You can either employ both controller types individually, or you can also combine them. The module possesses various sets of parameters for controller tasks, but can also be configured individually. Let's move on to the other special functions. A lockup relay saves a signal state until it is specifically reset. If retention is switched on, then, should the power supply fail, that signal will remain pending at the output as was current before the power failed. A separate reset input allows you to reset the signal state to 0. The lockup relay is also known as an RS flip-flop. The current surge relay also saves a signal value, just like the RS flip-flop. However, this can also be reset by a current pulse at the same input. The reset input implements a central off function. The signal text allows the user to read off the current system operating state quickly and easily on the controller display. There must be a 1 signal on the signal block input to display a signal text. The output must either lead to an additional block or be closed off with an open terminal or a flag. ASCII characters must be used for the signal texts. These are the upper and lower case letters A to Z, the numerals 0 to 9, and some special characters. Current system values can also be included in the signal text. The effect of the software switch is the same as a mechanical button or switch. It is used to reset the operating hours counter without additional components on the machine. You can use the shift register function to read off the input value and shift it bit for bit. The output value equals that of the configured shift register bit. You can change the shift direction using a special input.